Hello, my name is Otsuka and I work as a data scientist at Line. In this session, I will talk about how the data scientists and machine learning engineers are collaborating and contributing to the product improvement at Line using specific project examples. This is a self-introduction. I joined Line in 2019 and I have been in charge of analytics of services such as Line Point Club that spans across many different family services of Line. But in this session, instead of showing an example of cross-service analytics, I will talk about an example of analyzing Line's sticker business. This is the agenda of this session. First, as an introduction, I will briefly talk about the data science and machine learning organization at Line. Next, I will talk about the Line Sticker Recommendation Engine improvement project as a specific example of collaboration between the data scientists and the machine learning engineers. Data Science Department and the Machine Learning Department are the organizations for data science and machine learning at Line, and they report to the Data Science Center. The Data Science Center is a company-wide organization that supervises the overall usage of data. Underneath this, the Data Science Department conducts data analysis, such as statistical analytics, to support the important decision-making of the business. The Machine Learning Department provides machine learning solutions, such as the recommendation engine, to the business, and also develop common machine learning platforms, such as targeting API that can commonly be used by each business. Let me show you the product improvement flow by the two organizations, Data Science Department and the Machine Learning Department. First is the machine learning design. The requirements of the business side is organized, and by clarifying that this is realized by machine learning, the machine learning engineers consider the model that is appropriate for the purpose. Next is the machine learning development. The accuracy of the model is improved through parameter tuning and attribute engineering. And then the model is validated through A/B test. The data scientists conduct diverse validation based on the quantified metrics to see if the initial requirement is met through online A/B test. Lastly, finding improvements. Based on the knowledge obtained from the A/B test, the areas of potential improvement of the model is identified and fed back to model design. By continuing this cycle, the machine learning model that is used in the product is continuously improved. From here, I will talk about the continuous improvement project of the Line Sticker Recommendation Engine as a specific example of the improvement process I mentioned earlier. Once you access the sticker shop, which is the marketplace for Line stickers, you will see a list of stickers that are recommended to you at the top of the screen. This is where the recommendation engine is used. Stickers for You serves as an important role in the Line sticker business. Let me show you some numbers. First is the business sales perspective. The purchase through stickers for you consists of 40% of the sales within the top page of the sticker shop, so it has a strong relation to the business revenue. Next is from the user traffic perspective. There is a massive traffic of more than 1 million clicks per day, and it is serving as a contact point for sticker purchases by many users. Next is from the user experience perspective. Recently, there are more than 10 million types of line stickers being sold. While there is such vast options to choose from, in order to provide a good shopping experience to the user, recommendation is an essential function. Sticker for You have been operated for many years, but we realized that its role is changing. I will explain what this means by sharing the background. In the past, many users were accessing the sticker shop when they considered purchase of stickers. However, currently, the Line UI has changed, providing more contact points for stickers. The users are able to naturally obtain information about stickers just by using the Line app without having to access the sticker shop. Let's look at the actual user behavior. Of the users who purchase stickers from Stickers for You, about 90% of the users are also purchasing stickers from other purchasing methods. You can see from this data that the users are interacting with stickers-related information in multiple contact points. By summarizing the above information, we consider the roles expected for the Sticker for You. Conventionally, because the contact point for stickers were limited, there were stronger needs for recommendation that would widely cover the stickers that the user may want to purchase. In order to do this, we needed a simple recommendation that captures wide and shallow preference of the users. But now, because there is more diverse contact point for stickers, the users who view Stickers for You are the users who are proactively looking for stickers. For such users, we thought that we need to provide a way allowing the users to discover new stickers that were never met before. In order to do this, we need to understand the preference of the users even more and recommend a wide variety of stickers. The keyword here is diversification of recommendation. I will now talk about the specific activities to realize the diversification of recommendation. As I mentioned earlier, conventionally, simple recommendations were demanded. We used naive Bayes model as the recommendation model. Naive Bayes model is a simple recommendation model limiting the number of parameters by not handling the dependencies among attributes. As the new model to realize diversification of recommendation, this was the model we first considered. The model we used was the graph-structured neural network. By making the user and item information as high-level feature vectors, the user preference can be captured more deeply compared to the conventional naive Bayes model. From here, the data scientist will validate the model. First, the assessment metrics for the model is chosen. There are several patterns for this. First candidate metric was the sales generated via the recommendation. These metrics only related to recommendation are typically used in A/B tests. However, this may overlook the impact of sales generated by other areas such as sticker ranking or search. So, you may make wrong decisions if you only assess based on the metrics limited to recommendations. Second candidate metric was the total sticker shop sales. This is good because it's holistic. But if you only look at the total, you will not be able to validate whether the initial objective of diversified recommendation is realized or not. Third candidate metric was by item sales, such as major stickers or minor stickers. If the sales of minor stickers are increasing, it means that the stickers that were not recommended before are now being recommended and being purchased, so this can be a good metric to validate the diversification of recommendation. Finally, we will validate the model by using total sales and the two metrics, major and minor package, in parallel. Like you see here, the appropriate assessment metric will differ depending on the objective, so the data scientists who understand the business data considering the metric is an important process in model validation. Next, A/B test is conducted to assess the model. This graph shows the sales increase in percentage comparing with the as-is model. As you see in the center bar, as we expected, the sales of the minor package has increased, and we were able to confirm that the diversification of recommendation has been realized. At the same time, the total sales have also increased. The result itself seems to have no problem. But we did not release this right away, but instead the data scientist made further analysis on the A/B test result to identify potential areas of model improvement. Let's look at the changes in number of recommendation impressions. As you can see from the center bar, the minor package impression is increasing dramatically. What I want you to focus is the gap between sales and impression lift that is shown in red arrow. The gap represents, despite the increase in total impression, there are more cases where they are not translating into sales. Meaning that there may be some issue with the accuracy of the recommendation. So we went and searched the cause. By looking at the actual recommendation cases, we came to one hypothesis. This was that maybe the characteristics of the stickers are too abstracted. I will explain by using an actual example. For example, to a user who purchased a sticker in Osaka dialect, there were cases of recommending stickers of other dialects. These stickers are similar from an abstract meaning of both being dialects, but users actually purchasing both would be limited. So we thought that by suppressing the abstraction level for the attributes may improve the accuracy of the recommendation and fed that hypothesis back to the machine learning team. Based on the earlier hypothesis, the model was reconsidered. In order to suppress the abstraction level for the attributes, we considered a simpler network structure model. The difference between the earlier model was the introduction of a convolution layer called light graph convolution. With this, the abstract conversion within the layer was simplified, making it a simple network structure. Once again, A/B test was conducted to assess the model. For comparison, result of the A/B test on the first model is this. The right graph shows the A/B test result for the second model. With the second model, the sales of the minor package improved even more. With this, the gap between the sales and the recommendation impression lift became smaller, and you can see that the accuracy of the recommendation has improved. Also, we were able to achieve the total sales being doubled. At the end, the second model was released, and this is being used in various sticker shops in many regions. That is all for the case study. Now for wrap-up. In this session, I presented the relationship between data scientists and machine learning engineers at Line using specific project examples. The models that were developed by machine learning engineers using advanced technology are validated by data scientists from an overall business perspective, and the points of improvement are fed back. Line is continuing with this cycle to continuously drive product improvements. That is all. Thank you very much.